I'm Anil Kumar, and in this video we will discuss continuity of a function. The question here is, show that the function f of x equals to 1 minus square root of 1 minus x square is continuous on the interval minus 1 to 1. Now whenever we talk about continuity, we say that during the interval when the function is continuous, limit exists and limit is equal to the value of the function, right? So what we need to prove here is that the limit exists. This is first part, and second, the value of limit, or you can say value of function, is equals to the limit for that point. So that is a very important criteria which we need to prove. Now this function is kind of special since it has a restricted domain. So let's figure out the domain of this function. So we have square root of 1 minus x square. That means 1 minus x square should be greater than or equal to 0, right? So that gives us that x square should be less than or equal to 1, or x is less than or equal to 1 but is greater than or equal to minus 1. That means our function is defined in this domain, right? So we can write here that the domain of f of x is d over x equals to from minus 1 to 1, right? So the function could be continuous in this domain as it is defined. So that's kind of important criteria to look into, right? So that is one part which we have seen. Now let us try to prove the continuity. I would also like to draw your attention on one more important consideration, and that is that this particular function is actually continuous between this domain. So it has a limit. It has outside limit. So it is on both the ends, right? So in such functions, we also consider that this function is defined. So our function f of x is defined from right side of x equals to minus 1 to left side of x equals to plus 1, right? So that is the interval where it should be continuous. It is defined in this interval, and therefore we need to prove that this function is continuous within these limits. Why I wrote this? I wrote this because what we need to really prove is that the limit of the function up as it approaches any point in the domain is a well-defined limit, right? So as x approaches a, limit of the function f of x could be written as limit of the function as x approaches a, where a is, so we say a belongs to the set from minus 1 to 1, okay? So limit of this function is defined as 1 minus square root of 1 minus x square, right? Using the properties of limit, we could write this limit as limit x approaches a for 1 minus square root of limit as x approaches a for 1 minus limit as x approaches a for x squared square root, right? So that is how we can write it using the properties of limit. Now as you know, limit for a constant is the constant itself. Within square root we have limit of a constant is 1, and here I can substitute a, so I get 1 minus a square square root. Now you can clearly see that the limit of the function at any point a is actually equal to the value of the function at a, right? So if I substitute a for x, I get the same 1 minus 1 minus a square. Now since the limit exists, correct, and it is same as that of the value of the function for any value a in between the given interval, we know that the function is continuous between this interval, right? Now since the function is defined within this interval only, what we also need to figure out is what is the limit as x approaches minus 1 from the positive side. Does it exist or not, right? And what is the limit when x approaches 1 from the negative side? Does it exist or not, right? So if I write 1 here, then I get a value which is 1, right? If I write minus 1, I get a value which is 1. So both these limits, what we see here is 1, right? So right side limit for the boundary condition on the left side and the left side limit for the boundary condition on the right side both exist, right? And therefore we confirm that this function is continuous within the given interval. Now as an added exercise, what you can do is you should rearrange this equation and then sketch it. If you sketch, what will you get? So in this limited space, let me sketch the function for you. It will be a circle, half circle, as shown here, where these points are from minus 1 to plus 1, right? So this is minus 1 plus 1, and the maximum value at this point, as we've seen, is 1, correct? So that is the limit. So that is the function we are talking about. You could actually rearrange and then also find the equation, right?